So hello, my name is Yes Kenny and today I will cover stack organization and function call execution in CPU. I will explain five subparts of stack memory, organization and function call execution in CPU. Stack memory, push and pop, stack pointer, function calls, call and return. What is a stack memory? Real life analogy. Think of a stack of a plate. You can only add a new plate on top and remove a plate from the top. You cannot take a plate from the middle. Like LIFO characteristic. LIFO rules. Last in, first out. The last item added is the first to be removed. Memory area. A special section of a RAM reserved for temporary data storage. Auto manage. CPU automatically use the stack during function calls. Fast access. Very fast CPU has a specially register to manage it. In right hand side, I will cover all three stack item 1, item 2 and item 3. Item 3 is currently added, currently pushed. Like two operation, I will explain. Push, stack operation, push and pop. Like first one, push, adding to stack in three subparts. SP, stack pointer, decrement by 1. Data is written at the new SP address. Top of a stack now point to new item. Use when entering a function. Same as in left hand side, I will cover pop operation. Pop removing from state. Data is ready from the current SP address. SP increment by 1. Pop of a stack now point to previous item. Use when returning from function. Key register use. SP stack pointer. Always pointer points to the top of the stack. Updates on every push of pop. PC program counter stores the address of the next instruction on to execution. FP frame pointer. Likewise, stack frame structure. Every time a function is called, the CPU create a stack frame, a decided memory block for the function. In left hand side, I will in show block type, local variable, save register, return address, parameter. In detail, I will explain what goes inside a stack frame. Parameters, value sent to the function like argument. Return address, CPU returns where to return after function ends. Save register, improvement register value save temporarily. Local variable, variable create inside the function. In 7 step, I will cover step by step in detail, and I will explain. I hope you all are explained. First, call instruction execution. CPU encounters a function call in code, instruction call when first step. 2. Second, push return address. Current PC meaning next instruction address. Program counter is like PC is pushed into stack. Push parameter. Function argument are pushed into the stack. Jump to function. PC is updated to the function starting address. Step up stack frame. FP is a set. Local variable space is allocated on stack. Execute function body. Function run its instruction using stack data. Restore and return. Stack frame is removed. Return address is popped. CPU jump back and call and return. Okay, these one all are covered in my friend by Mohak Nasid. Thank you.
So my topic is stack organization and function call execution in CPU. So my friend has done the video from PPT number 1 to 5. I will consider from PPT number 5. So we'll see function call step by step. The number first step is call instruction executed. CPU encounters a function call in code. Step number 2 is push return address. In this current PC means next instruction address is pushed onto stack. The third step is push parameters. Function arguments are pushed onto the stack. The fourth step is jump to function. PC is updated to the function static address. Fifth step is setup stack frame. FP is set. Local variable space is allocated on stack. Sixth step is execute function body. Function runs its instruction using stack data. And the last and seventh step is restore and return. Stack frame is removed. Return address is popped. CPU jumps back. Now we will see call and return instructions. Call instruction, what it does, it transfers control to a function. The first step is push return address, that is PC plus 1 onto stack. The second step is load function address into PC, and the third step is CPU starts executing the function. For example, call function address. Now we will see the return instruction. It returns control back to caller. Here the steps are, first step is pop return address from stack into PC. Second step is restore saved register if needed. And the third step is CPU continues after the original call. Here we are given a simple code example in C language. We can refer to that in order to understand the call and return instructions. Now we'll see the stack overflow and recursion. So first of all, what is recursion? A recursion that calls itself is called recursive. Each call creates a new stack frame on top of the previous one. The stack grows with every recursive call. Now in stack overflow, actually what happens? The stack, in short, the stack has a limited size in memory. If function calls go too deep, that is infinite recursion, stack grows beyond its limit. Stack overflow. Program crashes with a stack overflow error. Now to fix it, always have a base case to stop recursion. And here are some recursion stack visuals. We can see it factorial 1 top, then factorial 2, factorial 3, factorial 4, and main base. Now the summary and key takeaways from this PPT. First of all, stack memory. Special RAM area using LIFO, that is last in first out order. Push and pop. Push adds data, pop removes, both via stack pointer, that is SP. Stack frame. Block created for every function. It holds parameters, return address, and locals. Call instruction. Saves return address on stack, jumps to function code. Return instruction. It pops return address, restore execution back to caller. Recursion. Function calling itself is recursion. Create stack frames, needs base case. Thank you.